Hey y'all, and welcome to chapter 1. We are going to start with intercepts and standard form. So first let's look at some definitions. The x-intercept is going to be where a graph crosses the x-axis. Depending on your graph, sometimes this might happen in more than one spot, but in this graph below, we can see that we cross the x-axis at 3. And we just want to make sure that we always list our intercepts as ordered pairs, unless the question is only asking for just the x value or just the y value. So in this first blank, the x-intercept in the graph below, it crosses at 3, but we want to go ahead and write that as 3, 0. And that just makes it really clear that we're talking about a point, and that point is the x-intercept because the y value is 0. We don't go up or down at all. Okay, similarly, y-intercept is where we're going to cross the y-axis. This only happens once on a function. If you cross the y-axis more than once, you fail the vertical line test, so it's not a function. You might have graphs that do that, but it's not going to be a function. So the y-intercept in the graph below, again as an ordered pair, is going to be 0, 4, which just makes it very clear that you go 0 in the x direction, and so it is 4 on the y-axis. Okay, throughout this course, you're going to hear us talk about the x-intercept with a bunch of different words. I don't really know why we need so many, but it's just good for us to know because it'll show up on ACT, it'll show up on SAT, and you need to know that all of these mean the same thing. So roots, zeros, and solutions are all still talking about what is the x-intercept of the graph. And that's a really good shortcut to remember. This solutions one, if we're asking for solutions on ACT or SAT, if you can graph it on Desmos real quick, you can find the solutions just by looking at those x-intercepts. Okay, so in the problems below, we have to find the x and y intercepts, and then we're going to graph those lines. In order to find the y value, in order to find the x-intercept, we're going to set the y value equal to 0, because remember, every single x-intercept is going to be x, 0. So that y value is always going to be 0. Similarly, to solve for the y-intercept, we're going to set that x value equal to 0 for the same reason, because every single y-intercept is going to be 0, some y value, where that 0 is always the x. So good things to keep in mind. Nice easy tricks for finding those intercepts. So let's go ahead and start. Example 1. We are going to, on the x-intercept, set that y value equal to 0. So 0 equals negative 2x plus 5. And then we can go ahead and solve for our x value, and that's going to tell us what the x value of that x-intercept is. Write this as a decimal if you want to. I just tend to like fractions because I don't really have to do too much extra thinking. And remember, we just want to format that as an ordered pair. So 5 halves, 0. And that's going to help me graph my function. If I can find 5 halves, or maybe that is easier to graph if we put it in decimal form. Remember, we can use our graphing calculator to change a fraction to a decimal. Okay, so 2.5, 0, so I'm on my graph, going to go over to 2.5 on the x-axis. I'm going to put a dot there so I know my line goes through that point. Okay, let's go ahead and do the same thing for the y-intercept. I know my y-intercept is going to be 0, something, so I'm going to go ahead and set the x value equal to 0 in that equation above. So y equals negative 2 times 0 plus 5. And we can go ahead and type in this whole right side of the equation into my calculator if we need to. And we get 0 plus 5 is 5. Since y was already isolated, it was nice and easy to solve for that. So as an ordered pair, 0, 5, I can go ahead and put that. And if we remember back in geometry, we only need 2 points to make a line. So I have my 2 points to make a line. We can go ahead and do our best to connect those with a straight line there. And there is my graph of y equals negative 2x plus 5. It's not a bad idea to label our graph. There we go. And we can even see too that this, we're going to review this in the next lesson, but this is written in slope-intercept form, if you remember that. So as a nice little review, we have a y-intercept of 5, yep, and a slope of -2. So if we look here, we go down 2 over 1, down 2 over 1, down 2 over 1. So that also matches graphing this line with slope-intercept form. So two different ways that we can graph these lines so far. Okay, so let's do the same thing with B. B, we're finding the x-intercept. So I'm going to set that y value equal to 0. And notice I moved that negative sign up in the numerator there. It's just so it doesn't look like part of the fraction bar. Sometimes I notice if I'm being a little bit quick with my writing, I'll lose a negative if I don't put it up in the numerator. So that's a nice little trick that we can do. I'm going to go ahead and multiply both sides by the reciprocal. Because this -6 is going to cancel out with this -6. This 5 is going to cancel out with this 5. So I'm just left with 1 times x, which is just x. So I have x equals. Then I can also do some simplifying over here. The negative and a negative are going to cancel out. This 2 is going to cancel out here. And now we have 5/3. We could also use our calculator for that, right? If you're not super comfortable with fractions, I'm absolutely fine with us. Let's change that color. Using our calculator to solve that. Okay, remember we need to write this as an ordered pair. And let's go ahead and graph this. So 5/3 is going to be, there's 3/3, 4/3, 5/3. Okay, y-intercept. I'm going to set the x value equal to 0. Or if we remember how to read slope-intercept form, we can easily identify the y-intercept that way. And I can go ahead and put that on the graph, 0, 2 is right there. Then I can go ahead and connect this. Let's see. Try to do that as straight as possible. Most importantly, we just go through these 2 points that I indicated earlier. Beautiful. Okay, example number 3. This one looks a little bit different. It's not in slope-intercept form, but that's okay. It's still the same exact rules. For the x-intercept, I'm going to set the y value equal to 0. Okay. Write that as an ordered pair. And this one might be, oh, careful with the numbers we choose to write. Okay, this one might be better for us to go ahead and write as a decimal. So this is going to be -4.8, I believe. Please check me with the calculator, make sure I didn't mess that up in my head. But I'm pretty confident it's -4.8. So I'm going to go just a little bit short of -5 there. And now we can do our work for the y-intercept. So y-intercept, I'm going to set the x value equal to 0. This one's going to turn out much nicer, huh? Oh, goodness. What have I done? I am just all over with copying the wrong numbers down. We got to be careful. Use your brain. Okay, now that I've copied that down correctly, I don't know where the -2 came from. So now we have -4y, divide both sides by -4, and we end up with 6 there. That's why I always say check me, because, you know, I am perfectly capable of making mistakes just like you are. Beautiful. Okay, so that is finding the x and y intercepts algebraically. Moving on to the back. So standard form has a couple of requirements that's important to go over. So linear equations can be written in standard form. That's going to look like this, where x and y are on the same side. Some rules are that a, b, and c must be integer coefficients with no common factor. So that means that if I can divide all of them by 3, I should go ahead and divide everything by a 3 so they don't have a common factor anymore. If they're all even, I can go ahead and divide them all by 2. Okay, another rule is that a must be positive. So if a is negative, I need to go ahead and multiply everything by a negative, change all those signs, so that way a is positive. And the last rule is that a and b cannot both be 0, but one of them's allowed to be. And we'll talk about that in an example coming up. Okay, so which problems from example 1 is written in standard form? Let's pop back and look. So example 1, we have this one. We talked about is in slope-intercept form. X and y are on different sides of the equation. I could rewrite this so it's in standard form by adding 2x to both sides, but the question didn't ask me to rewrite, it just asked which one's already in standard form. Okay, so again, b, still in slope-intercept form. And it also has a fraction, so that's definitely not in standard form. But if I look at c, c looks like it has all those correct requirements there. So we have integer coefficients. We have no common factor. I can't divide them all by a number. And a is positive. That first number there with x, 5, is positive. So it looks like I have standard form on problem number C. C. And if we want to go ahead and copy that down, not a bad idea. It was 5x minus 4y, not 2y, equals negative 24. Beautiful! Alrighty, write each equation in standard form. So I need to go through my rules and make sure that I follow all the rules for standard form. So this one looks like it's in standard form already. A, b, and c are integers, good to go. A must be positive, and that's my issue here, is that that a value is currently negative. So I'm going to go ahead and multiply everything by -1. Make sure I distribute that to every single term. I like my rainbows. Okay, so I end up with 5x minus 6y equals 12. And the last thing I need to check for is, can I divide them all by a common factor? And I cannot. 5 is prime, and it doesn't go into 6 or 12. So there we go. Okay, B. So we need x and y on the same side of the equation for standard form. So I'm going to go ahead and start by subtracting 2x. The x one has to go first, so I'm going to rewrite it in this order. Okay, I have integer coefficients, so that's looking good. There's no common factors, so that's good. But again, I have that leading coefficient is negative, and I don't want that. So I'm going to go ahead and multiply everything by -1, change the sign of every single term, so that we end up with a positive a value. Alrighty, on to C. So C looks like a nice easy start. X and Y are already on the same side, but we need to move this constant. So let's add 24 to both sides. I have integer coefficients. A is positive, but kind of sneaky. They are all divisible by 3. So I need to go ahead and divide every single term by 3. And I guess this looks a little funny. Most of the time you're just used to one operation on each side. So I can divide this whole side by 3. We just need to remember we're distributing that. We need to divide both of those terms by this 3. So 3x plus 2y equals 12. And it's worth just checking to make sure there's not another common factor. So 3 goes into 12, but it doesn't go into 2. So, and they're not all even, so that is going to be my final answer. Okie dokie. So the definition of standard form states that A and B can't both be 0. So let's look at what happens if A and B were both 0. So we have 0x plus 0y equals C. Okay, 0 times anything is 0. Again, 0 times anything is 0. So we just end up with 0 equals C, which is not the equation of a line anymore. It's not the equation of a line. Okay, but I can, it does say one of them is allowed to be 0 in the definition up above, right? It says, but one can. Okay, so let's look at why one of them can. Okay, so if I had 0x plus by equals C, then I'm going to go ahead and divide both sides by b. Okay, C and B, remember those are standing for just different numbers. So y equals a number, that is going to be a horizontal line. And we'll talk about that more later. So if you don't know how I know that, that is something we'll review, so don't panic right now. But I do know that that's a horizontal line. Horizontal. Okay, similarly, I don't really have room, so I'm just going to talk about it. If I let b equal 0 and I had ax equals c, I would end up with the equation x equals c over b. And y equals is a horizontal line, so I bet you can guess x would be a vertical line. So it is still the equation of a line there. Vertical line. Okay, so that's why one of them can be 0, but both of them can't, because it's just not the equation of a line anymore. Okay, a student says this equation is a standard form of the equation y equals 3/2 x plus 3. What's the student's error? Okay, well, maybe in order to figure out what the error is, we should try this problem ourselves, because that looks like standard form to me. A, b, and c are integers. There is nothing in common, and a is positive, so it doesn't look like anything's wrong right off the bat. Let's go ahead and solve this. Y equals 3/2 x plus 3. Okay, we know that the x and y have to be on the same side. So maybe we can already tell what went wrong, because I see something coming up. We have x and y are definitely different signs here. Okay, but we've never had to deal with a fraction, so the question is, what do I do? And in order to get rid of this fraction, we really just need to get rid of this denominator. So if I multiply everything by 2, and I'm actually going to be sneaky, I'm going to multiply everything by -2, because I also know that I don't want this negative sign in front. So I'm going to multiply everything by -2 and distribute that. The -2 cancels out with the negative and the 2 in the denominator, so I am just left with 3x minus 2y equals -6. So it looks like the student's error is they just got two of those signs wrong. They had two positives for the 2 and the 6 instead of those both should have been negative. So we do need to describe the student's error, right? Because it asks what is the student's error. So the student's error is the B and C values you can say have the wrong signs, or I'm going to say should have been negative. There we go. There is 1.0, and I will see you guys for the next video.